The significance of fission was lost by no country, not on either side of this incipient war. The first Heisenberg report came on the 6th of December 1939, just a few months after fission had been discovered, when Heisenberg wrote to the Armament Authority and said that a fission nuclear reactor was feasible. Uranium would consist of the enriched form, that is to say, the kind of uranium where the total number of neutrons and protons added up to 235, not the much more common 238, and that this uranium-235 would make a powerful new explosive which surpasses the explosive power of the strongest explosive material by several orders of magnitude. Heisenberg said you would have to moderate, to slow down the neutrons, to make them cause fission by some kind of heavy water, that is to say, ordinary water with extra neutrons, or graphite. The geometry of the whole thing, he considered a spherical form or a cylindrical form, and he added that the separation of this uranium-235, which is less than 1% of the kind of uranium that you found in the ground ordinarily, for power was really going to be difficult. He calculated the need for tons of this uranium-235 in order to be able to get a reactor to really work. His second report, in February of 1940, was one where Heisenberg judged that graphite could not be used as a moderator to slow down the neutrons to allow them more easily to cause fission. This was confirmed by quite a good experimentalist, Walter Botha, only because the German experimentalists couldn't get the kind of pure graphite that they wanted, and the industrial grade that they had so many impurities that it seemed to confirm Heisenberg's judgment that graphite couldn't be used. If you couldn't use graphite to slow down the neutrons to make them more likely to cause fission, it meant you needed heavy water, that is to say, the hydrogen with extra neutrons attached to the oxygen, and that this could be used to slow the neutrons down. So where do you get the heavy water? Well, that they subcontracted to a plant in Norway. In February of 1942, the German Army Ordnance decided that nuclear weapons were simply not going to be part of the war because it was so difficult to produce the amount of uranium-235 that was needed. It would have been on a huge scale, roughly on the scale of the entire rocket program that the Germans were building, say a couple of $1 billion in 1945 equivalent. Or you had to be able to separate out plutonium, an element 2 above uranium on the periodic table, which also seemed incredibly difficult. So on both counts, German Army Ordnance decided that nuclear weapons were simply going to be out of the question. But to advance the project in any way, to move it forward, they needed this heavy water. And the plant that was designed to produce it, Norsk Hydro, was destroyed by sabotage after several very, very difficult attempts to destroy it. It was finally wrecked on the 27th of February 1943. The Germans had rescued a certain amount of the heavy water and were trying to ship it back to Germany when, again in an act of sabotage, the Norwegian resistance sunk a ferry with a full supply of heavy water on the 20th of February 1944. With that sinking, it almost became impossible to go forward in this project. But the Germans had achieved certain successes. In 1941, part of the project in Leipzig achieved some part of a chain reaction. They discovered that plutonium was an alternate way of building an atomic bomb other than the separation of this lighter isotope of uranium, uranium-235. They'd gotten the backing of certain parts of industry and the German army, and success looked like it might happen. But there followed a lot of conflict inside the German project itself about how far a neutron could get before it interacted by splitting a uranium nucleus, how much uranium you needed to go critical. Did you need tons, or did you need only a certain number of kilograms? What kind of moderators could you use? They'd ruled out graphite. They needed the heavy water. They couldn't get the heavy water. So there were many things that impeded the German project from getting very far, but it had gotten a start. Heisenberg, on February 26, 1942, met with German ordnance and said this: if one could assemble a lump of uranium-235 large enough for the escape of neutrons from its surface to be small compared with the number that actually causes more fission, then the number of neutrons would multiply enormously in a very short space of time. The whole uranium fission energy of some 15 million calories per ton would be liberated in a fraction of a second. Pure uranium-235, Heisenberg told the military authorities, is thus seen to be an explosive of quite unimaginable force. So it wasn't for lack of understanding that this could be a weapon and a source of power. It wasn't for lack of understanding that plutonium and uranium-235 were the right substances to look for. It was the scaling up that made it impossible for the Germans to proceed, coupled with misassessments of what graphite would be, what the free path of a neutron would be before it interacted, of the amount of the critical mass necessary, of the need to have very fast neutrons causing this explosive reaction, and therefore making it different from the kind of multiplication that would occur in a reactor where you want things to proceed in a controlled and slower fashion. So there were many aspects of the problem that ground it to a halt. But Heisenberg continued to rise in the hierarchy of German physics. In June of 1942, he was promoted. He defeated certain attempts to describe him as a white Jew, as some of the Aryan physicists were wont to call him. He had family relations with Himmler, who was able to clear his name and to tell the attackers to back off in their criticism of Heisenberg. Heisenberg went on to lecture about these questions of nuclear physics and possibly generating power or weapons. He briefed Albert Speer, the architect of the Third Reich, and other military commanders on the 4th of June, 1942. He briefed dignitaries at Hermann Goering's Aeronautical Research Academy in May of 1943. But both indicated that the reactor and the bomb had problems. Each dampened expectations for a rapid solution to be conducted inside the course of the war. For all these reasons, the Nazi bomb never advanced very close or even remotely close to actually building a workable bomb. But they did make steps towards making a reactor. They had formed pieces of it, and in fact, we can take a look at one of the chunks of uranium that had been used to try to build one of the reactors that Heisenberg supervised, and that was hidden but eventually discovered by an American mission that had been sent to try to capture what was known by the Nazis of their project. And they rounded up the physicists who were sent to a place called Farm Hall in Kent, in England. They captured the pieces of the reactor, and they found masses of documents that surrounded the project, which the Germans had hidden.